Bicycle hubs with internal gearing, such as this one, an 8-speed hub made by Shimano, and that one, a 7-speed hub also made by Shimano, promise winter cycling, commuting, that requires much less maintenance than the traditional setup with a cassette set and an external derailleur. You see, this arrangement of a transmission, this is a transmission, is all exposed to water, rainwater, snow, road salting, and all the abrasive action of the dirt that the precipitation forms carry with them, as well as the corrosive action of the salt. The grease from or oil from the chain gets spread out on all of the teeth on the cassette set, and that's a dirt and dust magnet. This arrangement needs substantially more maintenance than the internally geared hubs. It's difficult to compare this transmission ratio. You could say, like on my bicycle that I use, I have 11 teeth on the smallest one, 30 teeth on the largest sprocket, and I know what chain rings I use on the crankset. It's difficult to compare this transmission arrangement with the transmission arrangement of an internally geared hub. In this video, I'm going to do exactly that. I'm going to calculate what speeds do I get out of this bicycle in every single gear as it is assembled by the manufacturer, everything as mounted, compared to a bicycle that I used with an external cassette and derailleur. So, the numbers that you need for this calculation are fairly straightforward. You need the number of teeth that are on the chainring here. This could be, in this case, 45 teeth on this Shimano, or a different number of teeth on this FSA. I'm going to count it. As well as you need the number of teeth mounted on the hub here. There's another chain ring here, or sprocket, and this chain ring mounted here does not come manufactured with the hub. The hub is compatible with a limited number of options here, but whatever the bicycle manufacturer chooses to fit out the bicycle model with, that's the number of teeth that you're gonna get on the hub here. So this can vary up and down, not a whole lot, but there are some options here. I'm gonna work with the exact number of teeth that are mounted on this particular hub here on this bicycle model, as well as that one over there. I'm gonna count the actual teeth on these chain rings. I also need the actual number of transmission ratios that are inside the hub that's published by Shimano. It doesn't give me or anybody actual number of teeth, it just gives me transmission ratios. And one more number, I need the driven wheel, this is the driven wheel's actual circumference. I just measured this with a steel tape measure. I just wrapped it around. Both tires on both bicycles have been inflated to exactly 80 psi of pressure. This one is a Schwalbe Marathon Plus tire, 700 by 32C, and that one is 700 by 35C Kenda Quest tire on the silver bicycle. So I measured the circumference in millimeters on both of the tires, so now the calculation can be done. It's very straightforward. In theory, the calculation goes as if you do one rotation on the crank arm from, say, 12 o'clock position to 12 o'clock position, in all of the gears the hub comes with what is going to be the distance the tire rotates. Okay, so we're gonna, and after that distance we're gonna calculate kilometer per hours, we're gonna calculate speed. Very straightforward. So let's go into the class. I'm gonna show you the calculation on an Excel spreadsheet. And so this is how all the numbers look like when they are placed into a spreadsheet, and all the ground speeds have been calculated both for the 8-speed bicycle as well as the 7-speed bicycle. With the ground speeds calculated, I can directly compare the two bicycles against each other, as well as can compare my other bicycle with an externally mounted derailleur on it. That's on a separate spreadsheet, but here in column G I have the fastest speed, the slowest speed, and everything else in between in every single gear ratio that I have, and I can compare it top speeds, lowest speeds, and everything else in between directly with the internally geared bicycle models. Now, how did I get here? I'll show the formulas, and I will show you what these and explain what these numbers mean in these columns, and we'll zoom in as appropriate. The concept of transmission ratio needs a little bit of explanation, with the note immediately that Shimano, and I'm going to use Shimano's actual literature that they printed and published, they use transmission ratio and gear ratio interchangeably, as well as they use the words gear, sprocket and chainring interchangeably. I'll do the same, give or take a little, even though those are not quite the same mechanically, but they are the same mathematically. Okay, so starting with transmission ratio, which is abbreviated here as tranny ratio, I printed the words drive over driven, actually drive slash driven. That slash is the same as a fraction bar, but Excel doesn't really stack words vertically. Drive, the word drive should be in the numerator position and the driven in the denominator position, or instead of a slash I could include a division symbol, drive divided by driven. Division or fraction, it's the same concept. In the 8-speed bicycle model, the primary transmission ratio is 2.5. Well, it doesn't look like a fraction. So what's going on here? The fraction that's resulting in 2.5 is coming from the fact that, and here's just a simple calculator, that chainring with 45 teeth are fitted to the crank and the spindle, and that's the drive sprocket or drive gear, and the driven is at the rear hub, externally mounted or on a cassette, all externally mounted, but in this case it's 45 divided by 18 because there are 18 teeth on the smaller sprocket, and there's your 2.5. A fraction was converted to decimal. The transmission ratio is listed as a decimal number, even though it is a fraction, and you need both the numerator and the denominator to come up with this 2.5. I have here links to the bicycle models. This red and black, this is the 8-speed model, and this gray one is the 7-speed model. Again, the hub needs to be considered for the calculation together with the externally mounted sprocket on it and the chainring, as well as whatever size of tire they have on it, inflated to exactly the same pressure so they can be comparable. So that's the 7-speed, that's the 8-speed. The primary transmission ratio is specifically given here by the manufacturer on the crank, 45 teeth, or on the chainring, and 18 teeth mounted externally to the 8-speed hub. So this is the 8-speed hub, and one 18-tooth sprocket is mounted here in this space here, somewhere here at the edge. So everything else is internal, but there's one external. You can see it in the video. Same on the 7-speed variant, one external sprocket is mounted there, and the retailer says that the number of teeth on that sprocket is 20 here, and there are 38 teeth on the chainring. So the transmission ratio is 38 divided by 20, which is featured in this column here in the table. That gets you 38 divided by 20, 1.9. Now, that's the primary transmission ratio. This can be changed a little bit. Shimano here, again, if I click on Shimano's dealer's manual, it gets you a number of choices here. So for the 7-speed hub, they recommend that at the front, you can have 36 teeth, 38 teeth, or 36 teeth on the chainring, but if you have 38, they recommend that you mount 18 18-tooth sprocket for the externally on the internally geared hub. So 38 divided by 18 is their recommended transmission ratio, which must be somewhere close to 2.1. However, the retailer went with a different arrangement. So instead of, Shimano here recommends 13 over, or let me just get you a little sideways there, 13 and 18. This manufacturer went 13 with 20. Now obviously 13 and 20 are nowhere shown in the chart. As a result, the bicycle is not going to fall apart, but because the sprocket at the rear is 20 instead of Shimano's recommendation, which is 18, that means that the bicycle will be a little bit slower, meaning that it's better suited for hill climbing, which is what the retailer had in mind for living in the Pacific Northwest and in British Columbia, lots of hills. That also means that the bicycle will be slower at its fastest speed, or it's in fastest gear ratio or gear arrangement, but again, it's suited and designed to work on hill climbs better. The 8-speed bicycle, Shimano recommends, again, straight out of Shimano's dealer's manual. I just clicked on it, so that's what you see at the top. It says dealer's manual, and it has the 8 and the 11 speed hub in this manual. There's the chart. So for the 8-speed bicycle, they recommend that the primary transmission ratio, which they call sprocket ratio here, be between 2 and 2.25, and again the retailer made it 2.5 because the front, it says gear, but of course it's a chain ring, so that's why I said don't worry about it too much. It's the same thing mathematically. So Shimano recommends 45 teeth for, or 42 or 39 for an 8-speed hub, teamed up with a chainring at the crank, 45 teeth, and this be teamed up with between 20, either 20, 21 or 22 tooth sprocket that goes to the rear. The retailer again fitted 18 tooth sprocket at the rear, making the bicycle faster than it was maybe not designed for, but maybe what Shimano recommends. So this bicycle, the 8-speed one, is a little bit faster than Shimano recommends. It can be slowed down if the 18-tooth sprocket on this bicycle with the red one, this one, if this 18-tooth sprocket is replaced by the 20-tooth sprocket, or the 21 or the 22 as Shimano recommends, it's going to be slower a little bit, or better suited for hill climbing, either which way you want to look at it. So that's how these numbers work. If you slow down a bicycle to make it better suited for hill climbing, it means once you hit flat grounds or level terrain, it's not going to be as fast, given the same cadence, 60 RPM. Of course your RPM can be different, it can be 70, that's what's repeated here further down, but what I'm saying is if you are, whatever pace you set, whatever cadence you set, you can calculate your speed. It's predictably. It doesn't matter how much wind blows or whether you are actually going uphill or downhill. Like I said, this number is the speed is a resultant mathematical certainty given no slip. It doesn't matter which way the wind is blowing or how steep you're going uphill. If you are able to do 60 RPM, you have the leg muscles to do it, your bicycle will be doing that speed given these transmission ratios. So that's where these numbers come from. They come from Shimano's recommendation, the dealer manual, or Shimano's specs sheet here. With these gear ratios, as they call it, same as transmission ratio, you can see I grabbed the numbers 0.5, 0.67 all the way to 1.6 and just copied them over here into this column 0.5 to 1.6 with all the decimal digits. We don't have the actual fractions that go in here, but we don't need them. I just need the final decimal number. So that's transmission ratio or gear ratio, whatever. Same thing mathematically. And for the 7-speed hub, Shimano's got the specs here without decimal dots or commas. No big deal. These numbers, this is obviously 0.6, 0.7, all the way up to 1.3, 1.5. That's how the numbers are entered here in this column. So the calculation is really straightforward, but it needs one more number, the tire size, which is 2.2 meters or 2,200 millimeters, but meters will get you fewer zeros in the formula. Same 2.185 meters, not 2,185 millimeters, so just put a decimal dot there. And you can see that the formula is very straightforward. Multiply the RPMs with that number in meters, with that number that doesn't have a unit of measure, with those numbers, each line by line or row by row, and that's gonna get you all of the speeds that the bicycle can do with that hub, with that tire, with that sprocket at the rear, and with that chainring at the front. Same repeats for the 7-speed, same formula. I'm using that cell consistently, 60 RPM to be multiplied by that number, that number, that number, multiplied by 60, divided by 1,000. Get closer a little bit because that's not gonna get, that cannot be really zoomed in. So that's the formula, how it looks like. And if I go back to the, if I go back to the 8-speed hub, those are the cells that are multiplied together side by side, multiplied by 60, divided by 1,000, and that's going to get you kilometer per hours. If this one is in meters, that's important. So that's how these transmission ratios look like, and the calculation looks like. Now I can compare my either the 8-speed bicycle versus the 7-speed bicycle as it is fitted out with the sprockets that are used by the retailer. This bicycle could be slowed down a little bit, like I said, by fitting a 20-tooth sprocket to the rear hub externally. But that's going to bring down the top speed as well, but will be better for hill climbing. And if I go back to my bicycle that's got externally mounted derailleur and the externally mounted cassette set on it like this, then my fastest speed will be 36 kilometers an hour and my slowest is basically 8.99, so that's 9. So I'm between 9 and 36, and here I'm between 10 and 32. So obviously 8 speeds is not the same as 11 speeds, and but I can compare the bicycles. How fast am I going in every single gear ratio that the bicycle comes with. So I hope this arrangement of numbers makes sense. I'm not going to do the calculation for you, so don't ask. This is how the math looks like. And you don't need an Excel spreadsheet for this. You can just do this with a calculator and scribble down the numbers. But this is how it looks like in Excel, where I can just update the numbers, whatever, if they change. And I can see the changes or the new speeds calculated. If this primary transmission ratio is lowered to between, like Shimano recommends, between 2 and 2.25. Let's go back to here, this figure. Between 2 and 2.25 by changing the rear sprocket, putting on, instead of the 18 that it comes with, put on a 20, then I can recalculate these speeds really fast. So that's why it's in a spreadsheet. So that's how the bicycles can be compared. It's a bit of work, but hey, there's no more guessing left in it. It's clearly laid out. So, thank you very much for watching. That was a little bit of math. I hope your head is not hurting. Keep on cycling.